Good morning.
Good morning.
How we doing, people?
Good.
Alright, so real quick, you guys, I realized that during first period, I realized there's a lot of adjustments that I have to make to this lab. So it's really important that you guys follow instructions the first time so that we can waste no time, so that I can help make sure that you guys learn as much as we can from this lab. So to start off today, I need tip sheets out, and your notebooks out. I need your Mass Car Lab out. Your Mass Car Lab that you picked up yesterday and that we started. And my expectation is that you are silently completing your do now. Miguel is silently completing his work. Melissa is silently completing her work. Alondra is silently completing her work. You guys have 5 minutes to silently complete your do now. Is that 4 minutes? 2.5 more minutes? Those pencils moving. Carlos is silently completing his do now. Eyes up, mouth closed in 3, 2, 1. Jessica's active listening. Brandon's active listening. I see those beautiful postures for beautiful people. Good morning.
Good morning.
Okay, who can tell me Newton's second law? That awesome song? Mm-hmm. Alondra, what do you think? Force equals mass times acceleration. Who agrees with that? Woohoo! Alright. So I'm gonna ask this second question first. What units do we use to label force? What units do we use? Who's that really famous scientist that we always throw his name after we do force problems? Francisco. Newton's. Who agrees with that? It is Newton's, right? What will it one day be? Means, right. Just kidding, it won't ever be meanies, but it's Newton's after Sir Isaac Newton, right? Okay, why no naked numbers in science? Why is it important that we always use units? Louise.
Because we won't know what they represent.
We won't know what they represent. Right. So like what if I told you guys I want 16? Or like I ate 68. Or I am 8,000. I'm 8,000. And 8,000 what, right? That's why we use units. Okay? So we always have to use units so that people know what we're talking about. How many of you go grocery shopping with mom, dad, aunt, uncle, grandma, grandpa? as you add more food in your cart, is it harder or easier to push? Harder, right? Okay. And then, is mass the same thing as weight?
No.
Talked about this a couple times. Who thinks mass is the same thing as weight? Who thinks they are different? Who wants to explain why they're different? Cesar.
Because mass is different than weight because weight depends on how much gravity there is.
Weight depends on how much gravity there is. Good. Does our mass change?
No.
No, right. Okay. How much force do you need to push a 1,000 kilogram car at a rate of 5 meters per second? Angela. 5,000 newtons. Who agrees with that? Good. Okay. So, yesterday we got to our intro to the MassCar lab, right? Alright, so quickly I need you guys to, on the count of 3, read today's objective as best you can. 1, 2, 3.
Warriors will demonstrate application of Newton's second law by describing the relationship between mass and distance traveled using evidence from the MassCar lab.
That was outstanding, guys. Okay? So today what we're going to be doing is we're going to be focusing again on Newton's second law. We're going to be doing this awesome lab that's really, really hard, so we're going to get right to it. But what we're going to be focusing on is like what happens when we add more mass. So what happens if we add mass in the real world, what happens if we apply the same force? Will it accelerate as quickly? Will Newton's law hold true? So that's what we're going to be focusing on today. But instead of testing acceleration, we're going to be testing distance. So we're going to be adding more mass, we're going to be using the same force, but instead of measuring acceleration, we're going to be measuring distance, just because it's easier for us to do in this lab. So we're kind of using distance traveled to substitute for acceleration. Okay, so lab safety. I want you guys to take 1 minute and read through those yourselves, and then on your worksheet, I want you to pick what you think are the 3 most important. I want you to pick what you think are the 3 most important and silently write those down. Okay, I need 3 hands up, and I want to hear 3 different rules. Well, what'd you pick?
Report any accidents to the teacher immediately.
Report any accident to me immediately. Good. Cross, what'd you pick?
Perform only authorized tasks.
Perform only authorized tasks. Good. Brandon, what'd you pick?
Don't touch anything without asking.
Don't touch anything without asking. Okay. Excellent. So all of these are incredibly important. I'm just putting them up again, guys, because we haven't done a lab in a while. We had science fair, which was this big, long time where you guys had to follow all of these rules, but now that we're back doing a lab, I just wanted to remind you that following instructions is so important. So it's really important that you guys follow all of these directions, that you don't touch anything until we get started. Okay, so I want you guys to take 2 minutes, and starting at the description on your worksheet, I want you guys to read over the description, materials, and procedures for this lab. You have 2 minutes, and we're going to get started. So I need to see everybody's pencils down and eyes on the materials and the procedures. 2 minutes of silent reading. Go. Miguel silently reading. 2, 1. Brandon's eyes are on me. Shakira's eyes are on me. Okay. So here's what we're gonna do. You guys are gonna get into your groups in one moment. Not your science fair groups, but your regular lab groups. Okay. We're gonna pass out materials, and I'm going to go over these instructions again, but I just noticed in my last period that I wasn't as clear the first time, so I want to be very explicit, okay? So all of you, this is your data table. You guys are going to have 15 minutes to make sure this is all filled in, okay? What that means is you guys are going to do a trial. You're going to do 3 trials with 3 different masses. So the first time your card is not going to have any pennies in it. The second time your card is going to have 5 pennies. And the third time your card is going to have 10 pennies. And you guys are going to do 3 trials with each of those masses. And then you're going to collect the average. And then we're going to talk about our concluders. But I just want to be very clear. You do trial 1 with no pennies, trial 2 with no pennies, trial 3 with no pennies. Then trial 1, trial 2, trial 3 with 5 pennies. Okay? Good. So what I'd like to do is I'd like this row and this row to switch into your lab groups. Go. Take about 1 minute so we can just quickly. To look like, I need eyes up here. Alma's eyes are up. Okay, so you guys are going to lay out a straw track on your desk. And we're going to measure how far the car goes when we apply constant force. So I'll talk to you about what constant force is in 1 minute. But what I want you to do first is, what do you think is going to happen to the total distance traveled if we're adding more pennies? So as mass increases, I want you to think about what's going to happen to the total distance traveled as mass increases. I don't want you to tell me, I want you to write it as your hypothesis for this lab. You guys have 1 minute. The expectation is that everybody writes a hypothesis. Go.
Why are you recording this?
Yeah. Oh yeah. You want to go Okay, who wants to share their prediction? Who wants to share their hypothesis? Abby.
Yeah. I predict that as the mass of the car increases, the distance traveled by the car will decrease. Because the more pennies added, the heavier we get.
Excellent. So that was almost perfect. Abby predicts as the amount of pennies increases, the distance traveled will decrease because the more pennies will make it heavier. What's just a little bit more scientific way to say heavier so that we know, Carolina?
It has more mass.
Because it has more mass, right? Good. Okay, so next thing in your groups, what I need is, I need you to pick one supply person, one force person, one recorder person, one measuring person.
I actually have the force. It's 5%.
I like the enthusiasm. Okay, so who are my force people? Okay, you guys have everybody's eyes need to be up here, but force people. Okay, you guys have a very important job. Okay, it's incredibly important so that our data is good, so that our data is valid and reliable. I want you to use the same amount of force every time as best you can. So obviously it's not going to be perfect because it's impossible for it to be perfect, but I want you to use the same strength every time. So with 0 pennies, 5 pennies, 10 pennies, I want you to try it as best you can to use the same exact strength. Because would it be fair if on the 0 penny car you just kind of were not that strong, and then with the 10 penny car you're like, would that let us measure accurately how mass affects distance traveled? No. So we have to keep force as constant. Can we say that word, constant? Constant. So we want it to be constant as possible, like meaning equal the whole time. Okay? So my force people, please come up and grab an air blaster and a mass car. No. Just that. Okay, I need my supply people to very carefully come up, grab a ruler and straws. Woo. Okay, force people, let's put our air blasters down. I just need 2 hands up from everybody. 2 hands up from everybody. No, with nothing in your hands. Brandon. No, drop. 2 empty hands up from everybody. Okay. So, guys, we're almost there. I'm almost just gonna let you run free. We're almost. The last thing that I need to go over very quickly. Do we use inches or centimeters? Centimeters. Okay. So you guys are going to carefully make your straw track. You're going to take your straws. It does not have to be perfect. I repeat, it does not have to be perfect because it's going to take a long time if you make it perfect. I want them close to 2 centimeters apart. Just so that your car can travel along the track. So I need to see every group building their track right now. Go. Quick. We have to measure start and end from the back of the car and count how many centimeters the car traveled. Okay, eyes up here last time. 3, 2, 1. Eyes are up. Okay, you guys are going to have exactly 10 minutes. The expectation in those 10 minutes is that you do 3 trials with 0 pennies, 3 trials with 5 pennies, 3 trials with 10 pennies. Are we using different forces each time? What are we trying to keep force? Constant. Good. Okay. Who's ready? Who's ready? Tessie? One more time.
59 again.
Recorder, make sure you're recording this data. 5 minutes.
What did he do here?
Okay, again.
41. 41. 41.
Alright guys, so Abby's group had really good data. So I'm going to use her group as an example of what we're going to work on tomorrow with our own groups. Can I see pencils down, eyes up here? Jackie's active listening. Selwell's active listening. Thank you. Can we give Abby and her group a round? Okay, so quickly, to find the average, we add up each trial, and then we divide by 3 total. So as a class, I need all eyes up here. I want you to focus on the averages, okay? What do you notice? What do you notice as we added pennies? What happens to the average distance traveled? It decreased. Why do you guys think that is?
More mass is being
Because it has more mass. Right, and is there like a law or something that tells us that that's probably what's going to happen? Newton's second law, right? Force equals mass times acceleration. And instead of acceleration, we were using distance, right? So tomorrow, we're going to focus on this. Okay, and my teacher just gave me a great idea. I'm going to have you guys graph your data. Because some of you got the data that isn't as nice as this, and I want you to think about why that is. Yes? Oh, okay, Victor just made a great observation. What are these numbers missing? What are these numbers missing? Units. Very good. Okay. So to close out under your do now, I want you guys to silently complete this exit ticket. Under your do now. Please have your tip sheets out. Ashley is silently working on her exit ticket. see what that looks like in real life.